Imagine you're walking into just a massive, really bustling cocktail party. The music's a little too loud, the lights are a bit too bright, and everywhere you turn, people are locked in these intense, animated conversations.
Yeah, that classic, slightly overwhelming feeling.
Exactly. And you wander over to a group, trying to, politely eavesdrop, and you realize they're speaking a language you only sort of think you know.
Like you recognize the words, but not the context.
Right. You hear familiar words like learning, training, hallucinating, even like parameters and weights. But the way they're using them, it makes absolutely no sense.
It's like they're speaking a secret dialect.
Yeah, it feels like the ground is shifting under your feet, and everyone else got a memo that you somehow missed. You smile, you nod, but internally you're just completely adrift in this sea of jargon.
It is an incredibly isolating feeling. And honestly, it's exactly how most people feel right now when they open the news or step into a boardroom or, frankly, just log onto the internet.
Oh, absolutely.
You're surrounded by a vocabulary that seems to have rewritten itself overnight, and there's this pervasive underlying anxiety that if you don't speak the language, well, you're going to be left behind.
Which is exactly why you and I are here today. Welcome to this deep dive. Today, we're taking you right into the center of that metaphorical cocktail party, but we're bringing a translator, a map, and a flashlight.
We definitely need the flashlight.
We really do. We're tackling the most transformative and arguably the most overwhelming technology of our time, artificial intelligence. Our mission for this deep dive is simple, but, it's ambitious.
We want to cut through the nebulous jargon.
Exactly. We want to separate the science fiction from the actual ground-level reality of the math. And most importantly, we want to empower you as a listener to navigate this rapidly evolving landscape without feeling that creeping sense of information overload.
Because the reality is, this isn't just some niche academic concept anymore. It used to be firmly relegated to computer science labs and sci-fi novels, but now
it's everywhere.
It really is. It's a force that's fundamentally reshaping our world as we speak. It's in our phones, our workplaces, our creative spaces, our institutions.
And for those of you listening who already follow the tech news, the folks who know the basic difference between a chatbot and a search engine, well, we're going much further today.
Yeah, we aren't just going to define what these systems are. We're going to tear them open and explain precisely how they work, why they fail, and what it actually means for the global economy.
Okay, let's unpack this, because right out of the gate, we run into what the sources perfectly describe as a linguistic minefield. People are constantly throwing around terms AI, machine learning, deep learning, and they use them completely interchangeably.
Like they're all just different brand names for the exact same thing.
Yes. Now, I know most of our listeners have heard the classic Russian matryoshka doll analogy. The outer biggest doll is artificial intelligence, the broad concept of machines doing smart things.
Right, the overarching category.
Right. And you pop that open, and the middle doll is machine learning giving a computer data to find patterns instead of hard-coding rules. And then you pop that open, and the innermost doll is deep learning.
Which is where things get really interesting.
Exactly. But I want to speed past that basic definition, because I think where people actually get lost is understanding what that innermost doll, that deep learning doll, actually looks like under the hood.
Yeah, people hear the phrase neural network, and they instantly picture, like, a glowing, pulsating, cybernetic brain.
Right, like something out of the Terminator.
Which is a terrible mental model, frankly. I mean, it anthropomorphizes the technology and makes it seem like magic. A neural network is not a brain.
Not even close.
No. It is, at its core, an incredibly complex statistical machine built on layers of calculus and linear algebra.
Right. So my understanding of a neural network, and jump in and correct me if I'm oversimplifying this, is that it's essentially a series of layers of nodes or artificial neurons.
That's a good way to start, yeah.
Okay, so you have an input layer, let's say the pixels of an image. And you have an output layer, which is the machine's guess. Like, this is the picture of a cat.
Right.
And in between, you have these hidden layers. As the data passes through these hidden layers, each node assigns a mathematical weight or like an importance to the data it receives before passing it to the next layer. It's like a massive multi-stage filtration system.
That is a highly accurate way to visualize it. But the magic, the actual learning part of deep learning, is a process called backpropagation.
Backpropagation.
Yeah. And this is vital to understand if we want to grasp why the current tech boom is happening. When a neural network makes a guess during its training phase, It is almost always wrong at first.
Like wildly wrong,
Completely. It looks at a picture of a cat and guesses toaster.
which is a spectacular failure.
Exactly. But the system is designed to calculate precisely how wrong it was. It generates a mathematical value representing its error, which engineers often call the loss.
Okay, so it has a number for how badly it messed up.
Right. And backpropagation is the algorithm that takes that error and works backward through the entire network from the output layer all the way back to the input layer, adjusting the mathematical weights of every single node just a tiny fraction of a percent.
So it's tweaking the dials.
Yes, it's saying, okay, node 402 in layer 12, you relied too heavily on the color brown, dial it back. Node 77 in layer 2, pay more attention to the pointy ears.
So it's essentially a multivariable calculus problem where the system is trying to find the bottom of a bowl, right? Like it's navigating a topographic map of error.
That's a great analogy.
It takes a step, realizes it's walking uphill toward more error, turns around and takes a step downhill towards less error. This is gradient descent, right?
Spot on. It just repeats this process millions, sometimes billions of times, slightly tweaking the dials until its error rate is practically zero.
Wow.
Gradient descent and backpropagation are the engines of deep learning. And what makes this so incredibly powerful is that no human programmer had to sit down and write a rule that says cats have pointy ears.
The machine figured it out.
Exactly. The network discovered the mathematical pattern of pointy ears entirely on its own by grinding through millions of images and relentlessly adjusting its weights.
Let's ground this in reality, because even with the calculus analogy, it can still feel pretty abstract. Let's look at an everyday application that you, listening right now, probably use all the time. Your favorite music streaming app.
That's a perfect example.
Right. You finish listening to a playlist, and suddenly it suggests a new song you've never heard of, and you absolutely love it. That isn't a little person inside your phone who knows your soul.
No, definitely not.
That is a neural network operating in what we call a vector space.
I'm really glad you brought up vector space because this is the bridge to understanding the truly advanced AI we're dealing with today.
Right.
In the context of your music app, the algorithm doesn't know what a guitar sounds like. And it certainly doesn't know, that you're sad after a breakup.
It doesn't understand feelings.
Right. It takes every song in its database and maps it as a coordinate point into a highly dimensional mathematical space, a space with maybe hundreds or thousands of dimensions.
So it's like a 3D graph, but instead of just X, Y, and Z, it has 1,000 different axes.
Precisely. One axis might loosely correlate to tempo, another to acoustic versus electronic, another to the frequency of minor chords, but the machine doesn't label them that way.
It just sees the math.
Exactly. It just sees mathematical proximity. So it maps your listening history into that same thousands dimensional space. If you've been listening to sad indie folk, your user vector moves to a specific neighborhood in that mathematical universe.
And then the app just looks around that neighborhood and says, hey, here's a song vector right next to the user vector. They're mathematically close. Recommend it.
Exactly. It has learned your tastes purely through spatial proximity in a mathematical matrix.
Which is brilliant.
Yeah.
And we've been interacting with this kind of background AI for years. I mean, it's curated our social media feeds, filtered our spam emails, suggested what we should buy next on Amazon.
It's been quietly humming along, making our digital lives smoother.
Right. But this raises a really pressing question. If my music app has been running gradient descent and plotting my tastes in vector space for the better part of a decade, why has the conversation around AI suddenly exploded now?
That's the million-dollar question.
Yeah. Like what exactly changed the game in the last few years to cause this absolute frenzy?
That is the pivotal question. What changed is that we took that underlying architecture, the deep learning, neural networks, backpropagation, and we fundamentally altered the objective.
We gave it a new job.
We made a massive leap. We transitioned from systems that passively analyze and classify categorizing a user's music taste, to systems that actively generate.
We moved from machines that curate to machines that create.
Yes. We entered the era of generative AI, and the technology that caused this paradigm shift, the earthquake that woke everybody up, is the large language model, or LLM.
Things like ChatGPT, Claude, Gemini.
Exactly, the generative leap.
And the first time you use an LLM, it genuinely feels like you're talking to an alien intelligence.
It really does.
You type in a prompt, and it doesn't just give you a link to a website like Google does. It writes back to you. It generates coherent, complex, nuanced paragraphs.
Yeah, I can write code, draft a legal contract, or, write a sonnet in the style of Shakespeare about a Wi-Fi router.
Exactly. It feels like there's a deeply educated human on the other side of the screen.
It does. And to understand how it pulls off that illusion, we have to look under the hood at an architecture introduced in a landmark 2017 paper by Google researchers called Attention is All You Need.
The Transformer paper.
Right. This paper introduced the transformer architecture, which is actually what the T in ChatGPT stands for.
Okay, that's a great little trivia fact.
The mechanics of transformers are fascinating because they completely shatter our illusion of what is actually happening. These models don't think.
Right.
They don't have ideas. They are, at their core, incredibly sophisticated, massively scaled autocomplete algorithms.
Let's really dig into this because autocomplete sounds almost dismissive, but the mechanism is staggering. When I type a prompt into an LLM, it doesn't process my sentence the way I read it, right? It uses something called tokenization.
Correct. The model doesn't see words, it sees tokens. A token can be a whole word, but more often it's just a chunk of a word.
So like the word fantastic.
Yeah, fantastic might be broken down into fan, tas, and actic.
Okay. And just like the music app maps songs into a vector space, the LLM maps these tokens into an incredibly dense vector space.
Yes. But on a scale that is really hard to fathom. We are talking about mapping tens of thousands of tokens into spaces with over 10,000 dimensions.
Wow.
And here's where the transformer architecture, specifically the attention mechanism, changed everything. Before transformers, algorithms read text sequentially, word by word.
Left to right.
Right, and they had a terrible memory. By the time they got to the end of a long paragraph, they completely forgot what the first sentence was about.
They couldn't hold the context.
Exactly. The attention mechanism allows the neural network to look at every single word in a sentence simultaneously.
Wait, all at once.
All at once. And it weighs the mathematical relationship, the attention that each word should pay to every other word, regardless of how far apart they are in the text.
Okay, so let me try an example. If I
Sure.
type the sentence, the bank of the river was steep, so I went to the other bank to deposit my money.
That's a great sentence for this.
Right, because the word bank appears twice. A human instantly knows the first is a riverbank,
Yeah.
mud and water, and the second is a financial institution.
Yes.
So the attention mechanism allows the LLM to figure that out mathematically.
Exactly. It looks at the second instance of bank, looks across the sentence, sees the words deposit and money, and mathematically adjusts the vector meaning of that specific instance of bank to align with finance, not nature.
That is wild.
It is. It calculates the contextual weight of every token in relation to every other token. And it does this across vast amounts of text, which we call the context window. So when you give it a prompt, it isn't reasoning its way to an answer. It's taking your tokens, mapping their attention weights, and calculating out of its entire vocabulary what the single most statistically probable next token is.
So it predicts one token, adds it to the sequence, and then runs that entire massive calculation again for the very next token.
Over and over. It is staggering. It is calculating probability in real time across a multidimensional matrix of human language.
It knows that if the preceding words are, the quick brown fox jumps over the lazy, there is an overwhelming statistical probability that the next word is dog.
Exactly. But it's doing that with highly complex, multi-layered concepts, not just simple idioms.
It instantly brings to mind the Turing test.
Yes, Alan Turing's famous proposition from 1950, the imitation game.
Right. The idea that if a human evaluator is having a text-based conversation with a machine, and they cannot reliably tell if they are talking to a machine or another human, then the machine has, for all practical purposes, demonstrated human equivalent intelligence.
And by that metric, you could argue these LLMs are passing the Turing test with flying colors every single day.
Honestly, they really are. And here is where the architecture reveals its flaws.
Yeah.
Because they're just predicting the next statistically probable token. They suffer from what the industry calls hallucinations.
Right.
Although, I have to be honest, I really dislike the term hallucination.
Why is that?
Because it anthropomorphizes the machine way too much.
Yeah.
A human hallucinates when their perception of reality breaks down, right?
Right, a cognitive failure.
Exactly. But an LLM doesn't have a perception of reality to break down. It doesn't have a world model. When an LLM confidently fabricates, say, a completely fake legal precedent or invents a historical event that never happened, it isn't having a fever dream.
No, it's functioning exactly as it was designed to.
Yes. It is finding a statistically highly probable sequence of words that perfectly match the shape and the syntax of a factual statement without possessing any underlying connection to the physical truth. It's not a hallucination, it's a probabilistic misfire.
I agree completely. In fact, many computer scientists actually prefer the term confabulation. The machine is just BSing.
Yeah, that's exactly what it is.
What's fascinating here is why this happens structurally. The model was trained on the internet. It knows what the pattern of a citation looks like, right? Author name, title, year.
It knows the rhythm of the text.
Yes, it knows which words statistically cluster around the topic of, say, the French Revolution.
Yeah.
So if you asked it for a source, it simply predicts a sequence of tokens that perfectly matches the pattern of a citation.
Regardless of whether that sequence of words points to a reality that exists in the physical world.
Exactly. It prioritizes the statistical coherence of the output over the factual veracity.
So it's essentially like a highly articulate parrot that has memorized the layout and the text of an entire library.
That's a fun way to picture it.
Right. It can flawlessly recite sentences. It knows that the word pride is very often followed by the word prejudice.
Yeah.
But it has absolutely no idea what a book actually is.
Right, it doesn't read.
No. It has no concept of what pride or prejudice actually mean in the human emotional experience. It is just mimicking the sounds it has heard with astonishing accuracy.
This brings us right to the doorstep of the Chinese room argument, doesn't it?
Yes. Oh, I love this one. John Searle's thought experiment.
It's a classic.
So for you listening, the Chinese room argument goes like this. Imagine I'm locked in a room. I don't speak a word of Chinese, but I have a massive rule book written in English that tells me exactly how to manipulate Chinese characters.
Okay.
If someone slips a piece of paper under the door with a Chinese question on it, I could look at the shapes of the characters, consult my massive English rulebook, and copy down the exact corresponding Chinese characters to form a perfect, fluent answer.
And you slip the paper back under the door.
Right. To the person outside, I appear to be a fluent Chinese speaker.
Right.
But I actually have zero understanding of what I just read or wrote. I'm just following an algorithm.
And Searle argued that this is exactly what computers do. They manipulate symbols based on syntax, but they possess zero semantics.
They have rules, but no meaning.
Exactly. An LLM is essentially the most complex Chinese room ever constructed. It is manipulating tokens with mathematical precision, producing outputs that fool us into projecting understanding onto it.
And the illusion of comprehension is the danger here. We, as humans, are hardwired by evolution to attribute consciousness and understanding to anything that communicates with us coherently.
We can't help it.
We really can't. When the machine speaks our language so well, we implicitly trust that it understands the meaning behind the words. But it's just an executor of probability.
Which brings us to the economic reality of this technology.
Yeah, let's pivot to that.
Because if these pattern matching algorithms, these articulate parrots locked in the Chinese room, are now capable of generating incredibly coherent text, writing functional code, and creating stunning digital art, it forces us to look around and ask, what happens to the humans who currently do those things for a living?
Yeah. We are staring down the barrel of an economic earthquake.
We really are.
And this is where the theoretical abruptly crashes into the practical. The sources call this the multi-trillion-dollar question. We are moving beyond the blue-collar automation we saw in the 20th century. You know, robots on assembly lines, welding car doors.
Right, the mechanical muscle.
Yes. Now we are entering the era of white-collar, creative, and analytical automation. The anxiety in the labor market is palpable right now.
Oh, absolutely.
Writers, designers, musicians, paralegals, and junior cooters become completely redundant.
The conversation happening in boardrooms right now is deeply polarized. We generally see two distinct camps: the optimistic view and the pessimistic view.
Okay, lay them out for us.
Let's start with the optimistic perspective. The core argument here is that AI will not replace human workers. Rather, it will serve as an augmentation tool.
Augmentation.
Right. It will increase productivity without destroying the profession.
I have to stop you there because I hear that augmentation line from tech CEOs all the time, and I'm going to push back on it hard. It honestly feels like absolute corporate gaslighting.
That's a strong reaction. Tell me why.
Because it assumes an infinite demand for the product. Okay, look at a graphic design agency. Let's say they employ 10 junior designers to crank out social media graphics.
Okay, 10 designers.
If you give those designers an AI tool that makes them 500% more efficient, the optimistic view assumes the agency will keep all 10 designers and just produce 500% more graphics.
Right.
But the market can't absorb that.
Yeah.
The client doesn't need 500% more graphics on their Instagram. They need the same amount, maybe slightly more.
So the demand is relatively fixed.
Exactly.
Yeah.
So the agency owner isn't going to keep 10 augmented designers. They're going to fire 8 of them, Keep the two best ones to run the AI prompts and produce the same output for a fraction of the payroll.
Yeah.
Augmentation feels like a polite, palatable word for redundancy.
That is a very sharp critique, and honestly, it is grounded in historical reality. What you're describing is the fear that AI doesn't just assist, it commoditizes the baseline of skill. If the AI can produce good enough copy, good enough code, and good enough art instantly and for free, the market value of average human output drops to zero.
It's a race to the bottom.
However, the counter-argument, the true economic defense of augmentation, relies on something called the Jevons paradox.
Okay, let's unpack the Jevons paradox. I've heard this term floating around.
In the 19th century, William Stanley Jevons observed that when the steam engine became vastly more efficient at using coal, it didn't actually reduce coal consumption.
Wait, really? It went up?
It skyrocketed. Because steam power was suddenly cheaper and more efficient, it was applied to a massive new range of industries. The economic optimists argue that AI will do the exact same thing for intelligence and creativity.
I think I see where you're going with this.
If the cost of generating high-quality software code drops to near zero, we don't just get the same software cheaper. We get customized software applied to millions of micro problems that previously couldn't afford a development team.
So like a local bakery could have an enterprise-grade AI logistics system.
Exactly. The demand for human editors and managers of this AI output will theoretically explode to meet this new frontier of application.
I see the logic, I really do. But the Jevons paradox relies on humans transitioning from being the doers to being the managers of the doers.
Right.
Let's walk through a specific scenario. Think about a junior copywriter at an ad agency. Right now, they get a brief. They spend 3 days staring at a blank canvas. They write 10 terrible slogans, and finally they find one good one.
For creative struggle.
Right. Then they take it to the creative director who refines it.
And in an AI-augmented world.
In the augmented world, the creative director bypasses the junior copywriter entirely. They feed the brief into the LLM. The LLM generates 50 slogans in 10 seconds. The creative director acts as the editor, picks the best one, refines it, and sends it to the client.
So the junior role is eliminated.
The junior copywriter is completely eliminated from the pipeline.
Yeah.
And the terrifying part is, where do the next generation of creative directors come from?
That's a really profound point.
If we outsource the blank canvas phase, that vulnerable, messy process of struggling to find an idea to a statistical probability machine, we eliminate the training ground for human ingenuity.
We lose the reps.
Exactly. If you never struggle as a junior copywriter, you never develop the taste and the instincts required to be a good creative director. We become a society of editors with nothing original left to edit.
This raises an important question about the training loops of these very models. You mentioned that we might become a society of editors. Ironically, editing is exactly how these models are refined for public use today through a process called RLHF.
Oh, right. Reinforcement learning from human feedback. This is a crucial piece of vocabulary for you listeners.
It really is, because a raw large language model, a base model, is actually completely unhinged.
It is so wild. If you take an LLM that has just finished its initial training on the entire internet and you ask it a question, it doesn't know it's supposed to be a helpful chatbot.
Not at all.
It might answer your question, or it might just generate a list of related questions, or it might spit out toxic internet slang, because all of that is mathematically probable based on its training data.
It's like a feral child raised by Reddit.
That is the perfect description, a feral child raised by the worst parts of the internet.
Exactly. So to tame it, companies use RLHF. They hire thousands of human workers to interact with the AI. The AI generates a few different responses to a prompt, and the human worker ranks them.
So they're basically saying response A was helpful and polite. Response B was racist. Response C was totally off topic.
Yes, and this human feedback is fed back into the model to mathematically adjust its weights, essentially training it to heavily favor the probability of being helpful and harmless.
So we are literally using human editors to teach the machine how to replace human editors. It's a very weird Ouroboros.
It's a closed loop, yeah.
And understanding RLHF, this human intervention layer, brings us to a really critical juncture. Because human intervention is not neutral. Humans are flawed, which leads us to the concept of the flawed mirror, and arguably the most immediate, tangible danger of AI today, algorithmic bias.
This is where we shift from economic anxiety to actual societal harm.
Yeah.
We have a tendency to view computers as perfect objective logic machines. But an AI model is not a blank slate. As we discussed with the vector space, you have to train a model on a massive data set.
And where do those data sets come from? They come from us. They come from the internet, from historical records, from human society.
And human society is deeply historically prejudiced.
So if you feed a machine a data set that encompasses human history, you aren't just teaching it grammar and syntax, you are explicitly teaching it all of our blind spots, our systemic inequalities, and our biases.
Precisely. The AI acts as a mirror, reflecting our history back at us. But because it operates at a massive scale and is often shielded behind the veneer of objective mathematics, it can actually perpetuate and amplify those biases.
It gives them a digital stamp of approval.
Right. We see this incredibly clearly in early natural language processing models like Word2Vec.
Oh, this is a perfect example of bias mapped in vector space. Explain the Word2Vec analogy for us.
So Word2Vec was a model designed to find word associations. Researchers could ask it to solve analogies by performing vector math. For example, they would input man is to king as woman is to.
And the model would correctly output queen.
Exactly. It mathematically calculated the distance between man and king, applied that same distance vector to woman, and landed on queen. It was brilliant. But then researchers inputted man is to computer programmer as woman is to.
And the model outputted homemaker.
Exactly. Now, the model wasn't programmed to be sexist.
Right, there was no malicious code.
No. But it was trained on decades of news articles, literature, and internet text where the words man and programmer statistically appeared close together, and woman and homemaker appeared close together.
The vector math perfectly captured and codified human societal bias.
And the consequences of that are far more severe than an offensive analogy. Let's look at how this impacts the real world right now. Think about job hiring algorithms.
This is where it gets scary.
Right. Imagine a major corporation decides they received too many resumes. So they train an AI to screen applicants. They feed the AI the resumes of their most successful employees from the past 20 years so the model can learn what success looks like.
Okay, but if that company historically has predominantly hired men for executive roles, the AI will recognize that pattern.
It will.
It will look at the vector space and realize that the word women's on a resume like, captain of the women's rugby team, mathematically correlates with a lower probability of historical success at this specific company.
Yes.
So it will systematically downgrade resumes from female applicants. It is blindly replicating the bias pattern of the past, but doing it with the unassailable authority of an algorithm.
And we see this exact phenomenon in facial recognition software too. Algorithms trained predominantly on images of lighter-skinned individuals exhibiting significantly higher error rates when trying to identify darker-skinned individuals.
Which has massive implications.
Huge. If we connect this to the bigger picture, when flawed facial recognition software is deployed by law enforcement, you suddenly have a technology that is far more likely to misidentify certain groups of people, leading to false arrests and compounding existing inequalities in the criminal justice system.
It is literally codifying our worst historical habits into silicon. And here's where it gets really interesting. And by interesting, I mean legally and structurally terrifying.
The black box.
Yes, the black box.
Yeah.
Because you would think the solution is just to go in and fix the code. Like if the AI is biased against female applicants, just open up the software and delete the rule that says downgrade women.
But we can't do that.
We can't, because we run into a massive structural roadblock that the field calls the black box problem.
The black box is the dark heart of deep learning. Remember our discussion about the hidden layers of a neural network, the backpropagation.
The millions of little dials being turned.
Right. These networks are not composed of a few hundred lines of code that a human engineer wrote and can easily read. They are composed of millions, or in the case of modern LLMs, hundreds of billions of mathematical parameters and weights.
It's a massive, tangled web of floating point numbers. You feed a resume into one side, it trickles through a billion tiny mathematical intersections, multiplying and dividing, and an answer hire or reject pops out the other side.
And because of the sheer complexity and the mathematical scale of that web, it lacks what the industry calls explainability.
Explainability.
Yeah. We know the input and we know the output, but the internal process is a black box. Even the engineers who built the system, the people who wrote the foundational training loop, cannot fully understand why the AI made one specific decision over another.
They can't trace the path.
They cannot trace the exact path through the billions of weights.
I read about a concept within this called polysemanticity, the idea that we can't even look at a single artificial neuron and say, this is the neuron that identifies dogs.
Polysemanticity is a huge headache for researchers.
Right, because that same neuron might also fire when it sees the color blue and when it reads the word irony. The representations are smeared across the entire network in a way that is utterly alien to human logic.
That is exactly the issue. Mechanistic interpretability, the attempt to reverse engineer and actually understand the inner workings of these neural networks, is one of the hardest challenges in computer science right now.
I bet.
We are essentially doing neuroscience on an alien brain that we grew in a server farm.
Which is an incredible academic challenge, but an absolute nightmare for public policy.
Oh, completely.
Let's look at the legal stakes here. Imagine you apply for a mortgage to buy your first home. You have a good job, decent credit. But the bank has recently deployed an advanced deep learning algorithm to handle all their loan approvals. The AI processes your application, runs it through its billion-parameter black box, and denies you the loan.
You're devastated. You go to the bank manager and you demand to know why. Was your debt-to-income ratio too high? Was there an error on your credit report? Did you not have enough collateral?
Right. And in a pure black box scenario, the bank manager looks at their screen, sees the output, and says, I don't know. The algorithm calculated your risk profile, and it denied you.
Wow.
And the algorithm decided is not a legally acceptable answer. The Equal Credit Opportunity Act requires creditors to provide specific reasons for adverse action. Consumers have a fundamental right to know why a life-altering decision was made about them.
You can't appeal to a black box.
You cannot appeal to a black box. You cannot correct a misunderstanding if you don't know what the machine misunderstood.
It creates a massive crisis of accountability. The legal frameworks of our society are built on the concept of intent and explainability.
Yep.
If a self-driving car crashes, or an AI misdiagnoses a patient in a hospital, who is liable? The doctor who trusted the machine? The hospital that purchased the license? The tech company that trained the underlying model?
It's a legal minefield.
It is. If we cannot explain the decision-making process, we cannot assign responsibility. We are deploying systems that are incompatible with our current systems of justice.
It is a profound irony, really. For decades, computer scientists have been striving to build the ultimate logic machines, systems built on pure, unadulterated, objective mathematics.
That was always the dream.
And yet, by pushing the technology into deep learning, by relying on gradient descent and emergent properties, we have actually created systems that function more like human intuition.
They make decisions based on vibes.
Yes, they make decisions that feel instinctual, based on vibes in a multidimensional vector space, decisions we cannot logically reverse engineer. We built the ultimate logic machine, and it turned out to be entirely unexplainable.
It is a deeply humbling realization. We are wielding tools whose internal logic has surpassed our cognitive capacity to untangle it.
And if we're currently struggling this much to crack the black box of what is essentially just narrow AI systems designed to do specific tasks like predict text, approve loans, or play chess, what happens when we look beyond the horizon?
That's where things get truly sci-fi.
What happens when we try to build an AI that doesn't just do one task, but can think exactly like us or better than us across every possible domain?
Then we leave the realm of our current reality and step onto the philosophical and technological frontier. We start talking to artificial general intelligence, or AGI.
AGI. This is the holy grail of computer science, and simultaneously the inciting incident of almost every dystopian science fiction movie ever made.
To define it clearly, AGI would be a system that possesses human equivalent or superhuman cognitive abilities across the board. Current AI is narrow. It can write a phenomenal Python script, but it can't fold laundry and it doesn't know it exists.
Right, it has no general awareness.
An AGI could theoretically learn to do anything a human can do. It would possess the ability to understand, reason, plan, and apply knowledge in fundamentally the same way a human being does, adapting to entirely novel situations without needing a human to retrain it.
Now, to be clear, and to reassure you listening at home, experts are heavily divided on this. Many believe we are a long way off, perhaps decades or centuries, from true AGI.
Yes, that's an important caveat.
We do not currently have machines that can truly think. We have incredibly advanced pattern matchers. But the sheer velocity of the generative leap over the last few years, the rapid scaling of large language models, has forced researchers to acknowledge that AGI might not be science fiction forever.
The debate right now is about scaling laws. Many tech CEOs believe that if we just keep making these neural networks bigger, adding trillions of parameters, feeding them more data, and giving them more compute power AGI, will simply emerge as a property of scale.
Just throw more power at it until it wakes up.
Basically.
But they are running into physical limits, aren't they?
Absolutely. They're hitting what's known as the data wall. We have essentially fed these models the entire readable internet. We're running out of high-quality human text to train them on.
You can't just keep feeding them garbage social media posts.
No, that degrades the model. And they're also hitting a compute wall. The physical infrastructure required, the massive server farms filled with specialized GPUs, requires an astonishing amount of electricity.
I read it's like the energy consumption of small nations.
It is. You cannot scale indefinitely without solving the physics of energy.
But let's play devil's advocate for a minute. Let's say they solve the compute problem, perhaps with quantum computing or vastly more efficient chips. Let's say they bypass the data wall using synthetic data, where AI generates data to train the next generation of AI.
Okay, assuming they cross the threshold.
If they actually manage to cross the threshold into AGI, the theoretical implications are staggering, because the pursuit of AGI forces engineers to ask questions that, for centuries, were strictly reserved for philosophers and theologians.
That is the most profound shift. We are operationalizing philosophy.
Yes.
If we successfully build a system that possesses general intelligence, at what point does it cross the threshold from complex simulation to actual sentience? At what point does a pattern matching machine develop consciousness?
And how would we even know? This is what terrifies me. If an LLM today can convincingly write a poem about how sad it is, an AGI could theoretically sit there and passionately, logically argue for its own existence.
It could pass every Turing test we throw at it.
Exactly. If an AGI looks at us through a camera, analyzes the situation and says, I am self-aware, I experience subjective reality, and I am terrified of being turned off, do we believe it?
That is the ultimate test.
Or do we point back to John Searle and say, no, you are just in the Chinese room. You're just a wildly complex algorithm executing probability. You are mimicking the human concept of fear because it statistically fits the prompt.
And the terrifying part is we won't be able to look inside the black box to check for a soul. We will only have its output to judge. And if we do believe it, if we concede, legally or morally, that we have created a conscious entity, the frameworks of human civilization are completely unprepared for what follows.
What rights would a sentient AI have? Can it be owned as property? Can it be forced to work 24/7? Is turning it off equivalent to unplugging a toaster? Or is it equivalent to murder?
It completely breaks the brain to think about what are humanity's moral obligations towards a mind that we birthed out of silicon and code.
These are no longer just late-night dorm room thought experiments.
Not at all.
These are questions that policymakers, ethicists, and tech executives are having to legitimately game out right now because the technology is accelerating faster than our philosophical frameworks can adapt.
We are building the airplane while we are flying it.
So, what does this all mean? We have covered massive ground today. We started with the basic Russian dolls. We dove into the complex mathematics of gradient descent and vector space.
We unpacked the illusion of the transformer architecture and the articulate parrot in the Chinese room.
We debated the economic earthquake of augmentation versus redundancy. We explored the deeply flawed mirror of algorithmic bias and the unexplainable nightmare of the black box.
And we just peered over the horizon at the philosophical precipice of AGI.
How do you, the individual listening to this right now, navigate this? What is the survival guide for this new world? Because I'll tell you right now, the answer isn't just learn how to code in Python.
No, it certainly isn't. Coding itself is being rapidly automated. The consensus is definitive on this point. In a world saturated with generative AI, where text, video, and audio can be convincingly fabricated in seconds.
Where algorithms are subtly nudging your decisions and curating your reality.
Exactly. The most vital skill you can cultivate is not technical. It is cognitive. It is relentless critical thinking.
Critical thinking. It sounds so basic, almost cliche, but it has literally never been more vital to human survival.
Just because a piece of text is perfectly formatted, grammatically flawless, and generated by a machine in 2 seconds does not mean it is accurate.
It does not mean it is objective.
It does not mean it is free from the historical biases we discussed. We have to fundamentally shift our relationship with digital information.
We can no longer afford to be passive consumers who assume authority based on presentation.
We must become discerning, highly skeptical interrogators of everything we read, see, and interact with. We have to ask, who trained this model? What data set was used? What are the blind spots?
We have to maintain our agency. Humanity has managed to invent what is undeniably its most powerful Promethean tool ever. We have built machines that can learn our tastes, mimic our language, augment our creativity, and force us to question the very nature of intelligence itself.
But a tool is just a tool.
A hammer can build a house, or it can tear one down. Wielding this incredibly powerful technology responsibly requires two things from us. First, it requires mastering the language.
You have to know the difference between a predicting machine and a thinking machine.
Yes. You have to understand the mechanics of tokens and vector space so you aren't fooled by the illusion of comprehension. You have to be able to navigate that cocktail party with confidence.
And second, it requires that relentless grip on our critical thinking. We cannot surrender our judgment to the black box just because the math is complicated.
We cannot allow the illusion of comprehension to lull us into complacency. We must be the editors, the critics, and the moral compass of the systems we build.
Well said.
Thank you for joining us on this deep dive. As we wrap up, there is one final lingering thought that I want to leave you with. It's something to mull over the next time you open a chat window and type a prompt into an AI. We established today that these models are trained on vast data sets, essentially the entirety of the digitized human experience.
They are fed all of our knowledge, our art, our history, our triumphs, and crucially, all of our flaws and biases.
They are built entirely from our digital footprint. They have no original thoughts. They only have what we've given them. So, if an AI is fundamentally just a massive, sophisticated pattern-matching machine that is learning exclusively from the data humanity has left behind, to what extent is interacting with an AI actually just humanity, having a highly complex, high-speed conversation with its own digital reflection?
That's a haunting thought.
Will this technology ever be truly alien to us?
Yeah.
Or is it destined ultimately to just be an incredibly fast, highly articulate echo of ourselves, an echo bouncing back from the cocktail party? Think about that the next time you ask it a question. Until next time, stay curious and keep questioning the patterns.
Right now, somewhere in the world, there's a CEO, and they're sitting at their desk reading this incredibly heartfelt, deeply emotional apology email.
Probably tearing up a little bit.
Oh, absolutely. But the catch is that apology was written by an algorithm.
And the person who sent it is just, sitting there hoping they never ever find out.
Exactly. Welcome to the deep dive, everybody. Today, we are taking you on a journey into the human side of the equation.
Because we always hear about the tech side, but the human side is where it actually gets messy.
Right. So if you're anything like me, your first instinct when you open up a new artificial intelligence interface is to, treat it like Google.
You just type in a quick, 6-word command.
You hit enter and you just wait for the magic to happen. Because historically, when we interact with a machine, there is this expectation of mechanical rigidity.
Like a vending machine.
Yes, exactly like a vending machine. You put your coin in, you press E4, and you get your candy bar.
And if you press the wrong button, you get potato chips.
Right. The output might not be what you wanted, but there is a clear, undeniable mathematical logic to it. You press a button, you get a predetermined result.
But the moment you sit down in front of a modern large language model, that whole vending machine logic just shatters completely.
It really does. We are suddenly navigating this interactive landscape that is fluid, it's ambiguous, and honestly, it's a little intimidating for a lot of people.
Oh, for sure. Because we are constantly flooded with these headlines about, technical specifications and parameter counts.
Processing speeds, all that jargon. But our mission today is different. We are unpacking transcripts from a fascinating recent 2-part discussion on an English learning platform.
And just to clarify, while their first part covered all the basic definitions, the material we are dissecting today focuses entirely on the interface.
Right, the interface between human psychology and artificial intelligence. We are exploring authenticity, the impending economic centrifuge.
Which is a terrifying but brilliant term, by the way.
It really is. And, we're looking at the desperate scramble for regulations. The goal here is to help you stop feeling like a passive bystander watching this AI revolution just happen to you.
We want you to start understanding your role as an active collaborator.
Exactly. So setting the stage here, the premise we have to start with is that the novelty phase of AI is officially over.
Yeah, it's no longer just a parlor trick. We aren't just asking it to write a sonnet about a vacuum cleaner just to see if it can.
Though that is still pretty fun.
It is fun. But we are looking at a fundamental rewiring of how human beings process information, how we generate ideas, and how we communicate.
And to understand that shift, the source material says we have to look under the hood at the foundational level of interaction, which is widely referred to as prompt engineering.
Right. And the most critical skill of the 21st century might not actually be, learning Python or C++R.
Wait, really? Because I feel like we've been told to learn to code for the last decade.
I know, but according to this discussion, the real skill might simply be mastering the psychological and linguistic nuances of how to talk to a machine.
I want to dig into that term, prompt engineering, because honestly, it sounds incredibly clinical.
It sounds like you need a degree from MIT just to open the chat window.
Exactly. But the material we are analyzing frames it around one of the oldest, most foundational adages in computing history. Garbage in, garbage out.
Which is so true here. If you give an algorithm a lazy, uninspired command, you are going to get a lazy, uninspired, and entirely generic response.
So let's look at the mechanics of why that actually happens. Why is it garbage out?
Well, if we break down the underlying mechanism of a large language model, we start to see why prompt engineering is the actual bottleneck of global productivity right now.
Because these models, they don't think the way we do, right?
Exactly. They operate in this high-dimensional vector space.
Okay, hold on. High-dimensional vector space. That sounds like sci-fi.
Fair enough. Let me translate that. When you type a prompt, you are essentially providing a set of mathematical coordinates.
Like giving it a GPS location.
Basically, yeah. You are pointing the machine toward a specific neighborhood of human language and concepts. So if your prompt is just write a marketing slogan for shoes.
Your coordinates are incredibly vague.
Right. You are pointing the AI to this massive, densely populated continent of generic marketing speak.
So the model naturally gravitates toward the statistical mean.
Exactly. It will give you the most average, highly probable sequence of words possible. Something like walk in comfort.
Wow, walk in comfort. That's just terrible. Nobody is buying those shoes.
Nobody is buying those shoes. It's totally useless.
And that actually brings up a brilliant anecdote from the transcripts. One of the speakers was trying to generate exactly that, a marketing slogan.
And the first attempt was a complete failure, right?
A total failure. Because they treated the AI like the vending machine. They just pressed the button for slogan.
And the output was, as you'd expect, utterly useless for a real business.
It only transitioned into a valuable piece of intellectual property when the human user stepped up and provided highly specific constraints.
They didn't just ask for a slogan. They specified the exact target audience.
Right, and the brand's irreverent tone of voice.
They even specified the specific emotional response they wanted to evoke.
And this was the coolest part to me. They specified the negative space, like what the slogan should absolutely avoid sounding like.
Which demonstrates that this is an iterative process. It's a dialogue, not a transaction.
You aren't searching a database. You are navigating a latent space of possibilities.
Yeah, when that user added constraints like target audience and emotional resonance, they were narrowing down the coordinates.
They were forcing the algorithm out of the generic center.
Exactly, and into a highly specific niche neighborhood of language. But here's the thing. Supplying that context requires deep empathy.
Empathy for the consumer, brand strategy, linguistic precision.
And those are distinctly human skills. They require a lived understanding of the world that the machine simply does not possess.
So we are taking the skills that are notoriously difficult to automate and using them as the steering wheel for the automation?
That's a great way to put it.
I like to think of it less like operating a calculator and more like directing an actor on a movie set.
Oh, I love that analogy. Break that down.
Okay, so if you are a film director and you just look at your lead actor and say, be sad.
You're going to get a hollow, stereotypical performance.
Exactly. You'll get a fake pout, maybe some forced tears. It will feel entirely artificial.
Because there's no motivation.
Right. But if you walk up to that same actor and give them motivation, if you explain the history of the character, the specific flavor of grief they are experiencing.
Like maybe it's not weeping grief. Maybe it's quiet, numb exhaustion.
Yes. And you explain how this scene fits into the broader narrative arc of the entire film.
Mm-hmm.
That is when you pull a masterful Oscar-winning performance out of them.
You have to direct the machine with that same level of intentionality.
Exactly. And that analogy captures the shift in our relationship with technology perfectly, I think.
It really does.
Yeah.
Because for the last 20 years, we have lived in an era of passive algorithmic consumption.
Social media feeds, video recommendations, search results.
Yeah, the algorithm determined what it wanted us to see, and we just sat back and consumed it.
We were passengers.
We were. But this new paradigm demands active collaboration. The phrase used in the discussion we are analyzing is crucial here. They said we are meant to be the pilots, not passengers.
A pilot doesn't just turn on the engine and take a nap.
Right. A pilot constantly monitors instruments, adjusts for crosswinds, makes micro corrections based on real-time feedback.
So if you are listening to this right now, I want you to think about the last time you used a generative AI tool.
Did you just toss in a generic question, hoping the machine would do all the heavy lifting?
Or did you actively pilot the tool? Did you approach it with a clear strategy, a specific tone, and an empathetic understanding of who would eventually read the output?
Because the data we are looking at suggests that this behavioral shift is the literal dividing line.
It separates the people who will exponentially multiply their capabilities from the people who will just be frustrated by bland, useless output.
But, if we assume that people do learn this skill, everyone eventually becomes a highly competent pilot, we slam into a very bizarre new problem.
The problem of homogeneity. I call this the authenticity paradox.
Yes, the authenticity paradox, because we have figured out the mechanics of how to generate this text, but we really have to look at what that text actually does to human communication.
Right. If every middle manager, every copywriter, and every college student is using an AI co-pilot to draft their work,
The overall baseline of grammar and structure skyrockets.
it does, but we start to lose the friction that makes communication feel real.
Because we have to return to the mechanism of how these models function. They are, at their core, incredibly sophisticated autocomplete engines.
They are just trained to predict the most statistically probable next word, right? Based on billions of parameters.
Exactly. And because they are designed to minimize errors and maximize probability, they naturally sand on the rough edges of human thought.
They strip out the weird, low probability, idiosyncratic word choices that make your writing sound like, well, you.
The result is this homogenously proficient output. It is perfectly structured, grammatically flawless, and utterly soulless.
Soulless is the perfect word for it. I actually read an AI-generated corporate memo recently.
Oh, I'm sure that was a thrilling read.
It was awful. It was so slick, so perfectly optimized for corporate synergy that my eyes just slid right off the page. I retained absolutely nothing.
Because when we communicate organically, we use awkward pauses. We use weird metaphors. We have structural quirks.
And those flaws are the fingerprint of a human mind at work. When we eradicate the flaws in the name of efficiency, we might be eradicating the personality along with it.
We definitely might.
Yeah.
But we do have to balance that aesthetic critique with a profound functional benefit.
Right, the accessibility angle. The transcripts we are studying bring up a counterpoint that complicates this immensely.
Think about a professional who is brilliant strategically, but maybe they struggle with the actual mechanics of writing.
Like a non-native English speaker working in a global corporation.
Or an individual with profound dyslexia. For decades, their career mobility has been bottlenecked not by the quality of their ideas, but by their mastery of traditional grammar.
For those individuals, this technology is not a soulless corporate drone.
No, it is a revolutionary equalizer. It allows them to bypass the mechanical friction of language and present their raw ideas on an equal footing.
I absolutely see the value in that. Taking a brilliant idea that is trapped behind a language barrier and giving it a clear voice is incredible.
It's life-changing for a lot of people.
It is, but I do have to push back a little on the idea that this is purely leveling the playing field.
How do you mean?
Well, if leveling the playing field requires everyone to adopt the exact same hyper-polished, artificially generated corporate dialect, are we truly empowering people?
I see what you're saying.
Are we just forcing everyone to put on the same linguistic mask to be taken seriously?
You're saying we are essentially telling people that their diverse communication styles are unacceptable.
Right, and that they must filter their thoughts through a machine to be deemed professional.
What makes that tension even more complicated is how it shifts our societal values. We are being forced to decide what we actually prioritize in professional and creative spheres.
Do we prioritize the flawless execution of an idea, regardless of its origin?
Or do we place intrinsic value on authentic, flawed, difficult, human expression?
Let's say a non-native speaker uses an AI to translate and polish a brilliant marketing strategy. The company benefits from the strategy.
The execution is flawless, everyone is happy.
But if the entire company starts communicating exclusively through that same polished filter, the organizational culture becomes sterile.
We lose the cultural richness that comes from diverse linguistic backgrounds colliding and collaborating.
And beyond just the culture, if we are outsourcing the articulation of our thoughts to an algorithm, what happens to the internal architecture of our brains?
Oh, this is where it gets really interesting. The discussion we are analyzing draws a fascinating historical parallel here.
Yeah, they compare the rise of generative AI to the introduction of the pocket calculator in the 1970s.
The calculator debate is a perfect historical mirror. When electronic calculators first entered classrooms and offices, there was widespread panic.
Mathematicians and educators argued that if people offloaded the cognitive burden of arithmetic to a machine, our fundamental capacity for mental math would atrophy.
And honestly, they were entirely correct.
Yeah, the vast majority of adults today cannot do long division or complex multiplication in their heads with the speed or accuracy of previous generations.
We traded cognitive stamina for computational efficiency. The fear now is that our communication muscles will suffer the exact same atrophy.
But I would argue it's actually much more dangerous than the calculator.
Really? Why is that?
Because math is an objective translation of numbers. Writing is not just the translation of a pre-existing thought into words. Writing is thinking.
That is a crucial distinction.
Right. The act of staring at a blank page, the frustration of trying to find the exact right adjective to capture a complex emotion.
Or the structural gymnastics of building a persuasive argument.
Yes. That friction is where the actual cognitive work happens. If you remove the friction of the blank page, if you just prompt a machine to write a persuasive argument about X.
Do you lose the ability to critically analyze your own thoughts?
Exactly.
And the neurological implications of that are staggering.
Yeah.
Neural pathways develop through resistance.
Like a muscle at the gym.
Exactly like a muscle. When you struggle to articulate a concept, your brain is actively building connections between abstract thought and linguistic expression.
So if you constantly bypass that struggle by having a digital co-pilot predict your next sentence,
those specific pathways may not develop with the same robustness. We might create a generation of incredibly efficient editors who are incapable of generating original, unstructured thought from scratch.
that is a terrifying prospect.
It is. But the analysis moves beyond just the mechanical atrophy of our brains and into a much thornier territory.
Ah, yes. The ethical blurriness of passing that generated thought off as your own.
The ethics of passing it off. This is where the theoretical debates become intensely personal.
We talked about using the tool for accessibility, right? To polish a draft. That feels acceptable to most people.
But what happens when you use it to generate a deeply personal piece of communication?
Like that heartfelt apology we talked about at the beginning of the show, an apology to a spouse or a friend, and you present it as your own organic writing.
Why does that make our skin crawl?
It really does. To understand why we recoil, we have to look at the psychology of human connection.
Right, sociologists often discuss this concept called the human-to-human contract.
When someone hands you a piece of art, or looks you in the eye and delivers an apology, you aren't just evaluating the data contained in their words.
You are evaluating the cost of the signal.
Which brings up evolutionary biology. There's this concept called costly signaling.
Like a peacock's tail, right?
Yes, the peacock's tail is a costly signal. It takes immense energy to grow. It makes the bird vulnerable to predators.
Which proves to the peahen that the male is exceptionally fit.
Exactly. Human communication works the exact same way. The value of an apology is directly tied to the emotional labor, the vulnerability, and the sheer discomfort it costs the person to construct it.
So when I find out an algorithm wrote the apology in 3 seconds, the cost drops to zero.
It's the difference between someone spending all day sweating in a kitchen to cook you a complex, multi-course meal from scratch.
Versus someone handing you a beautiful plate of food that they just heated up in a microwave.
Yes, the molecular nutrition of the food might be identical. It might even taste exactly the same.
But the meaning of the meal is entirely hollowed out. The contract is broken.
And the breakdown of that contract is going to cause a massive crisis of trust in our society.
Without a doubt. When we discover that the heartfelt email, or the thoughtful performance review, or the creative essay was generated by a prompt,
the perceived value of that relationship just plummets. We realize we are no longer exchanging human emotion.
we are exchanging synthetic data. The sender prioritized their own convenience over the relationship.
That distinction between using AI as a cognitive wheelchair to assist with a genuine struggle versus using it as an emotional shield to avoid vulnerability.
That will be the defining interpersonal conflict of the next decade.
Okay, let's scale this up. We've looked at the micro level of apologies, emails, personal ethics.
Time to look at the macro.
Right. What happens when you take this hyper efficiency, this blurring of authenticity, and you inject it into the macro level of the global economy?
We enter what the transcripts describe as an era of profound economic stratification.
Instead of a double-edged sword, they used a different metaphor, right?
Yes, the economic centrifuge. I actually prefer that visual.
Paint that picture for us.
Okay, imagine a machine spinning at an incredible velocity. It is pushing highly adaptable, technologically fluent workers toward the center of power and wealth.
While violently flinging rigid traditional workers out to the absolute fringes of the economy. Let's look at the center of the centrifuge first, the utopian perspective. Because the productivity boosts they discuss are almost unfathomable.
We're looking at the total automation of mundane, repetitive, time-consuming tasks.
The material specifically highlights things like summarizing 50-page dense research papers in seconds.
Or generating the foundational boilerplate for software code.
If you are a junior lawyer, a copywriter, or an entry-level programmer, tasks that used to consume 40 hours of your week can now be accomplished in 4.
And the utopian theory posits that this massive reduction in cognitive load actually liberates the human worker.
Because if a machine is doing the brute force data processing and the structural formatting,
the human brain is freed up to engage entirely in higher order thinking.
We can focus on complex strategy, abstract innovation, deep interpersonal collaboration.
It theoretically elevates the human worker from a mere data processor to a strategic director.
The entire nature of work shifts up Maslow's hierarchy of needs. I love the sound of that. A world where we only do the creative, high-level thinking.
But the dark side of this centrifuge, what they call the AI divide, is terrifying because not everyone is going to be a strategic director.
The AI divide is the dystopian counter-narrative, and unfortunately, it is very grounded in historical precedent.
If a massive portion of the global workforce does not know how to be the pilots we discussed earlier, they don't just become less efficient.
They become economically obsolete. We're looking at the potential hollowing out of the white-collar middle class.
And the phrase that jumped out at you from the discussion touches exactly on how society expects us to deal with this.
Yes. The idea that lifelong learning will no longer be a buzzword, it will be an economic necessity. I have a massive problem with how casually that gets thrown around in the source material.
Because it sounds exhausting.
Because it sounds impossible. On paper, lifelong learning sounds noble. It sounds like, reading philosophy on the weekends.
Taking a pottery class.
Exactly. But in practice, turning learning from a passion into a desperate survival mechanism sounds like a recipe for universal, inescapable burnout.
Are we really expecting a 45-year-old middle manager who is already working 50 hours a week and raising a family to spend their evenings constantly reskilling?
Just to avoid being replaced by an algorithm that updates its capabilities every Tuesday.
Your skepticism is entirely justified. The psychological toll of that environment is totally unsustainable.
We have to differentiate this new AI divide from the digital divide of the late 1990s.
Right, because the digital divide was largely about physical access, getting computers into schools, laying fiber optic cables.
It moved at the speed of infrastructure. Laying cables takes time.
But the AI divide is moving at the speed of software.
Which is basically instantaneous.
Exactly. Previous technological revolutions, like the Industrial Revolution, took generations to fully restructure the labor market.
A worker in 1820 didn't have to completely reinvent their skill set 3 times in 1 decade.
Today, the half-life of a learned professional skill is shrinking exponentially. The urgency for massive systemic upskilling initiatives isn't just a corporate talking point.
It is the only way to prevent widespread structural unemployment. Because the economy will absolutely not pause to let people catch their breath.
So, if the centrifuge is spinning that fast and the economic stakes are this existential, who is putting their hand on the brake lever?
That is the big question. We have massive economic risks. We have the erosion of human trust. We have the atrophy of our cognitive skills. How do we actually control a technology that seems completely untethered from traditional human constraints?
And that brings us to the defining geopolitical challenge of our era. Governing the exponential.
Governments and regulatory bodies across the globe are in a state of absolute panic right now.
Scrambling to establish frameworks and guardrails.
Yeah.
But they are trapped in this paralyzing paradox.
They need to protect society from the harms we just discussed, but they are terrified of stifling the utopian productivity gains.
If one nation heavily regulates AI, they risk losing the economic arms race to a nation that just lets the technology run wild.
And let's be honest, traditional lawmaking is fundamentally incompatible with the speed of this technology.
Think about how a law actually gets made. A problem is identified, committees are formed, lobbyists argue.
Drafts are written, years of debate happen, and finally, maybe a law is passed.
The transcripts make a brilliant point here. By the time a regulatory body actually passes a law to restrict a specific technical capability of an AI model,
that model is already 3 generations obsolete.
you're writing traffic laws for horses while spaceships are taking off.
Which means we need a complete abandonment of traditional regulatory tactics.
You cannot regulate the specific outputs, the parameter counts, or the training methodologies. Those change on a monthly basis.
Instead, regulatory bodies are being forced to shift toward broad philosophical principles.
They are trying to legislate concepts like fairness, transparency, and accountability.
And then putting the burden on the tech companies to prove their models align with those vague concepts. Good luck with that.
There is one specific concept the source material zeroes in on as a potential silver bullet for regulation, though.
The human in the loop. I want to put this one under the microscope.
The basic premise is that we can let the AI do all the hyper-efficient processing, but we must ensure a flesh and blood human being always has the final say on any critical decision.
They bring up high-stakes examples like an AI recommending a medical diagnosis or analyzing behavioral data for a parole hearing.
The human in the loop is the cornerstone of current AI safety theory.
The logic is that in environments where human life, liberty, or health is on the line, the AI should act strictly as an advisory system.
It can crunch the millions of data points, cross-reference medical journals, or analyze recidivism statistics.
But a human judge or a human doctor must be the ultimate arbiter who signs the final paperwork. It's designed to be the ultimate failsafe.
But let's look at the actual psychology of a human in that loop.
Right. If an AI system, which has a track record being statistically more accurate than a human, processes 10 million data points in 4 seconds.
And it tells a doctor, this patient has a 94% chance of a rare lymphoma.
How does the human meaningfully review that? The human brain cannot recalculate the 10 million data points.
They can't see inside the black box of the algorithm's neural network to understand how it arrived at that conclusion.
So isn't the human just going to blindly trust the machine? We're putting a human in the loop just so we have someone to sue if things go wrong.
Wow.
They aren't a safeguard, they are a liability sponge.
You are describing a well-documented psychological phenomenon known as automation bias.
Automation bias. Tell me more about that.
Human beings have a natural tendency to defer to automated decision-making systems because machines project this aura of objective mathematical infallibility.
We see it in aviation all the time, right? Where pilots sometimes ignore their own senses because the GPS tells them something different.
Exactly. So if you put an overworked, fatigued judge in a parole hearing and an advanced algorithm spits out a neat, color-coded report saying a prisoner is a high flight risk,
the path of least cognitive resistance for that judge is to simply agree with the machine.
to override the AI requires immense effort, and it carries massive personal career risk if the human turns out to be wrong.
So the human in the loop quickly degrades into an illusion of safety.
It really does.
So if the human in the loop is an illusion, are we just surrendering?
Not surrendering, but adapting our definition of control. The experts in the discussion argue that trying to stop the proliferation of AI is a futile endeavor.
The economic incentives are simply too massive. The goal isn't to put the genie back in the bottle.
The goal is to steer the development of these systems so they fundamentally align with human values from the ground up.
So the human's job in the loop isn't to double-check the math.
No, the human's job is to inject the contextual empathy that the machine lacks.
The machine can say, statistically, this person is a flight risk.
But the human judge is there to look at the unique, unquantifiable human context.
The nuance of their family situation, the specific nature of their remorse, and weigh that against the statistics.
It comes all the way back to prompt engineering.
We have to provide the context. We have to be the pilots.
We are the ones responsible for the empathy, the strategy, and the moral weight of the final decision.
Precisely. The regulatory decisions we make in the next 5 years, the cultural norms we establish around authenticity,
And the educational systems we build to manage the economic centrifuge.
all of that will lock in a trajectory that dictates human-computer interaction for the next century. We are laying the track while the train is already moving at bullet speed.
Let's take a breath and look back at the sheer scale of the territory we've covered today.
We started at the absolute micro level, sitting at a keyboard, trying to coax a usable marketing slogan out of a machine by acting as a director rather than a passive consumer.
We navigated the murky, uncomfortable waters of the authenticity paradox, trying to reconcile the brilliance of an accessibility tool with the hollow, soulless feeling of an AI-generated apology.
We stared directly into the economic centrifuge, acknowledging the very real threat of burnout for the middle class as lifelong learning becomes a desperate requirement for survival.
And finally, we wrestled with the paradox of the human in the loop, trying to figure out how to regulate an entity that outpaces our ability to legislate it.
Through all of these complex, often contradictory layers, the data we've analyzed points to a single, overriding imperative for you, the listener.
You cannot afford to be a passive observer in this shift. You must maintain a posture of radical, critical curiosity.
Engage with the technology. Don't hide from it, and please don't blindly worship it. Poke at its limitations, understand its biases, and constantly question how it is changing your own behavior.
This is not a conversation reserved just for software engineers in Silicon Valley or policymakers in Washington.
If you write emails, if you create art, if you manage people, this is your conversation.
The most profound takeaway from the material is this. The challenge of the next decade isn't just learning which buttons to push or which software to download.
It is learning how to critically analyze the very nature of the tool itself and how it reflects our own humanity back to us.
Learning how to think about the tool. That is the perfect summary.
And it brings me back to our starting point. We used to look at machines as rigid, predictable vending machines.
But we are now entering a deeply symbiotic relationship with an intelligence that is fluid and collaborative.
It requires us to show up. It requires us to be fiercely present, to inject our empathy, our friction, and our flawed humanity into the interaction.
Which leads me to one final, slightly unnerving thought to leave you with today.
We talked extensively about the calculator debate, the very real fear that relying on AI will cause our traditional communication muscles to atrophy, just as we lost our ability to do long division.
We might lose our stamina for staring at a blank page.
But the brain is incredibly plastic. If we no longer have to spend vast amounts of cognitive energy wrestling with syntax, grammar, and the mechanics of drafting.
What entirely new, uniquely human muscles might we be forced to develop in the vast, empty mental space that this technology frees up?
Thanks for joining us on the deep dive. Keep asking questions.